Hello, and welcome to In Praise of Raw Data, rematerializing astronomical images using sustainable print processes. So my name is Dr. Melanie King, and speaking next will be Dr. Claudia Mignone.
Astronomical images have a very long history of centuries and millennia with all sorts of graphical and artistic representation of scientific phenomena happening in the sky from all over the world. Then in the 19th century, the introduction of photography finally enabled astronomers to automatically record light coming from celestial objects. And that paved the way for a number of some of the greatest discoveries in the history of astronomy and astrophysics. In the mid-20th century, there have been some experiments with color photography using analog astronomical images. However, the way that most people image the universe and space has something to do with a number of events that happened around the 1990s. And those include the availability of digital detectors, the onset of the internet, and the development of digital image software for processing images. And right at that time, the Hubble Space Telescope was launched. And Hubble, with its stunning images that were processed for public consumption and readily made available on the internet, has contributed a huge deal to the way that the public imagines space and the cosmos. And then some 20 years later, JWST is truly Hubble's successor, not just for the great science it is enabling, but also for its role in contributing to shaping the public's imagination of space and inspiring audiences around the world towards astronomy and the fascination for the universe. Of course, with respect to Hubble, JWST observes well beyond the wavelengths of visible light, so into the near and mid-infrared domain of the electromagnetic spectrum. That caused a number of questions. So all these awe-inspiring images prompted questions online about how these images are made. These questions were already quite popular with Hubble, but they became even more popular with JWST over the past couple of years. So in our project, we decided to embrace these questions to explore how astronomical color images are made together with art and photography students. As a first research step to create our curriculum, we talked with JWST science image experts. We met with Joe De Pasquale and Alyssa Pagan, who are science visual developers at the Space Telescope Science Institute and are some of the people behind most of the JWST images that are available on the internet. And then we also met with Professor Mark McCaughrean, who is a JWST interdisciplinary scientist and has decades of experience processing infrared astronomical images. During these interviews, we combined our complementary perspectives to break down how astronomical images for public consumption are created. As an astronomy communicator, I am mostly interested in the chromatic approach, or the way through which astronomical images taken in different filters are combined by associating colors to each filter that are proportional to the actual wavelength in the electromagnetic spectrum. As an artist, instead, Melanie was mostly interested in artifacts, which are something that makes each image truly unique. So the key artifacts that we focused on in JWST images are summarized in this slide. In the first image on the top left, we see that the center of a very bright, highly saturated star appears as black. So that has to be manually removed. Then in the second image, we see the characteristic image of spikes that appears also around bright stars. And that is caused by the optical system of the telescope. And it actually depends on the telescope design. So it can be thought almost as a signature of the telescope onto the images. Then in the third image in this series, we can see another artifact that is caused by cosmic rays. Cosmic rays are highly energetic particles from deep space that impact the detectors. And here you can see them highlighted with little circles on the image. And finally, in the fourth image, in the lower right, you can see some striations that is known as readout noise in the background. After these research sessions, Melanie went into the studio to translate these astronomical imaging processes into photographic and printing techniques.
So for this project, this is a picture of the Carina Nebula. I wanted to use the image of the Carina Nebula because I was interested in the 6 pointed stars. The 6 pointed stars are an artifact of the James Webb Space Telescope. They're diffraction spikes, and it's because of the 6 mirrors on James Webb, so you wouldn't get this in a Hubble photograph. And it's very important for me to produce all of my images now in a sustainable way. This is done using the risograph process, which is a bit of a combination between screen printing and a Xerox or photocopy machine. So you have a master, which is cut out by the machine, which is based on the color separations that you do in Photoshop, very similar to how you would composite in astronomical imaging. And each of these lets a certain amount of ink go through the master, and you can do up to about 4 colors. The sustainable element of the risograph is the paper, so that's made out of recycled paper. The inks are from a soya base, so they're vegetarian. And the starch, the masters are made of starch, so they are completely biodegradable. Again, this is an image of pillars of creation, and you can see I've left in the overexposed cores. I find those really interesting as an artifact from the telescope. And again, this was produced using the risograph technique, but using only 1 color. And theoretically, it is possible to build up to 4 colors, but we weren't able to do this due to the availability of inks. And I made this in collaboration with Park Press, who are based in Margate. And then finally, this is an image of the Tarantula Nebula, which was given to me as an image from the James Webb Space Telescope Institute. And again, you can see some of the diffraction spikes on this image. This is a photograph that is produced using the screen printing process, and I worked in collaboration with a Birmingham-based photographer called Claire Hewitt, a botanical ink maker called Carolyn Morton, and a paper maker called Danielle Phelps, and they're working together to produce the first sustainable photo book. So we used a ink which was made from oak gall. So if you're not sure what an oak gall is, they're made when a wasp goes into a tree, and it leaves this highly tannin-rich object behind, which you can then make into ink. It was then printed onto paper made from coffee cups, and also made paper using cotton remnants that had been recycled into paper. So just to end, I'm just going to talk about some of the pedagogical possibilities for this project and what we're working towards. The next step that I want to do for this project is to make a duo-color cyanotype. So a cyanotype is one of their most ecologically friendly photographic processes that you can use, but you can also build up color through toning and using different botanical dyes to change the color of the image. And the idea behind this is that it will be easily replicable. Students will be able to learn about astronomical imaging, learn about how the James Webb Space Telescope works, learn about raw data, and also learn about sustainable printmaking techniques. So thanks very much for watching. Thanks from myself and Claudia Mignone, and I hope you find this interesting.
Welcome. My name is Arwen Hubbard, and I am an educator specializing in space science. I'm a podcaster and a NASA Solar System ambassador. So before we get into the idea of learner-driven questions, let's back up for a moment and think about the role of an educator. So in the past, the educator was the keeper of knowledge, right? But we live in a world saturated with information. And so if something is well understood, then most students can find that information without somebody there to help them. So what is it that the educator is doing then? Well, as educators, we are providing a connection for these students. We're helping them to make the connections between different ideas, not just here's the information, but how does this information fit and connect with other pieces of information? We're creating environments that really facilitate and empower their learning. So if we want to bring in some of the education buzzwords here, we are trying to create positive, empowering learning environments. We're really focusing on the self-efficacy of students, their belief in themselves and their ability. And today, what we're talking mostly about is their confidence in their curiosity and being able to follow their questions as a way to learn and engage in that material. And so we want to create learning environments in which not only do students have permission to be curious, but that is encouraged. That is something that we really want. We want to model that for them because that helps them learn, but also because that's how science works, right? Science is about asking questions and figuring out how to answer those questions. And as soon as those questions are answered, it opens up how many new questions, right? So learner-driven questions, this is a way to get the learner, the student, invested in the material. Now, hopefully, we're talking about astronomy here. This is a topic which is often a passion topic for learners. You usually don't have people in your astronomy course or coming to your lectures if you're doing outreach for your university or whatever it is. You usually don't have people coming who aren't already interested in space, like you might have in some of the other topics that students are required to take in school. So you already have a little bit of buy-in here. But by focusing on what it is that they are interested in, or what it is that they are thinking about, well, we're going to be able to do a better job helping them to really become engaged. So, what are our goals here? Well, obviously, we want to answer the question, or we want to help them to answer the question. That may be the situation sometimes, right? So we want to share the knowledge, but we want to do it in a way that asking questions, that is a good thing. We really want to grow and foster curiosity. And that goes back to creating a learning environment in which, well, learning can be done. Because when they are curious, when they're able to ask questions, they're going to learn the material better. They're going to be more invested in it. And of course, that's the ideal of a good scientist. So for me, I teach in a lot of different contexts, and I use this approach of trying to focus on the learner's question in many different situations. One of the places where it really shines is in my podcast. So my podcast is Found in Space, a science podcast for kids and teens. And it reaches students, learners, and their families around the world outside of a traditional educational context. But let me talk about the process. So these are very short episodes. The listeners have their parents write in a question that they have. And I have a strategy that I use each time. And this is really easy to apply to other situations. We're going to get into that in a moment, other contexts that you can use. So the first thing is to acknowledge the questioner, the learner. And that sometimes you might have their name, or sometimes it might be something as simple as great. Then you want to highlight the question, right? You are reinforcing that asking questions is good. This is something that you want to do. They're being emotionally rewarded for being curious, for trying to put these ideas together. Then I launch into the explanation of whatever it is. Then invite more questions. And this is really important, is to invite. So you've praised the fact that they asked questions. You're going to invite them to ask questions again. And you're not just inviting them, you're inviting all of the other people who are listening or who are engaging with you. Now, I'm guessing that most of you are going to be in other contexts. Some of you may be doing some sort of teaching or outreach on social media and online. In that case, the format that I talked about with the podcast works great, right? You can translate that pretty much one-to-one. But some of you are going to be giving public lectures. And you may not be dealing with young children. You might be dealing with graduate students or something like that, right? So you may be a little bit more restricted in how you are presenting because you have a specific agenda or a specific curriculum that you have to be teaching to or presenting to, right? So in this case, you might have to be a little bit more creative in thinking about, okay, how do I invite them to ask questions? Sometimes you may not have the back and forth with the actual student, so it may just be inviting them to ask those questions and hoping that they're kind of thinking about that in their head. But hopefully you'll have some interaction, some back and forth. So you can do things like start with some questions at the beginning. And you may pose some questions as if you were the student. And again, that's going to just invite them to be asking those questions. You might stop in the middle of the lecture, invite questions, get questions from the audience. Again, you might have to start with the first question to get them kind of going, and then direct the second half of your presentation around what they are interested in. Now, in a classroom setting, there's a lot of potential here. And again, that's going to depend on your age group, your subject, what requirements you have, right? But one of the techniques that I really love is question time. So you can have the students write their questions and hand them into you if you think you've got kind of a shy bunch, or you can have it out loud and use those steps that we talked about before. Right? Let's jump back to that about acknowledging the learner, highlighting the question. Although the learner might want to be anonymous, you still don't need to say their name, but acknowledge that the questioner did a good job by asking that. And you can use that as something for them to think about between classes. You can have them ask questions at the end of class, and you can come back with the answer and presentation in the next class, things like that. Now here, is what I think is really the most interesting part. This is where we're going to have some incredible opportunity. There will be times where you have some challenging questions. And the first one, love this one. Sometimes you will not know the answer to the question. And of course, as members of the scientific community, we know that's not a bad thing. That is actually an opportunity. And so we've got the opportunity to model, to demonstrate how much of a gift this is when we do come across questions. So I invite you to think about, okay, how are you going to respond to that? And don't pretend that you do know the answer, right? Because nobody knows all the answers. This is a time to say, I don't know. But, and whatever that but is going to depend on the question, right? So is it a question that the knowledge is out there, it's just not your field, or you don't have that number memorized? You say, I don't know, but let's find out. And you find out together, or you talk about how you'd find out. Now, it may also be a question that nobody knows the answer to. This is something like, what was before the Big Bang? Is there life in the European oceans around Jupiter? Questions like that. So in that circumstance, you have the opportunity to go, okay, I don't know, but how would we find out? And you can ask them questions back, right? So then you've got this back and forth of questions and answering together, and you can really start to explore together, not just this, handing down the knowledge. And you always have the opportunity to tie it back into whatever you're talking about. Now, the second thing that you're going to run into is that sometimes students have questions that have misconceptions in them, where they do need to be corrected about something that they've got wrong, right? So an example might be if they say, why is Mars so hot? Okay, well, Mars isn't hot, right? We know Mars is actually quite cold. But if you just say that Mars is cold, not hot, well, that doesn't really help with their sense of themselves, right? There are some rare people out there who are not going to be fazed by just being told that they're wrong right off the bat. Instead, what you can do is try to, again, you want to honor the fact that they asked that question and think about why would that be the assumption? Well, this is actually really interesting. We associate red with hot, right? With fire, or when you're heating up metal, it gets red hot. But, well, what does color tell us? Sometimes color tells us about temperature, but what else could color tell us, right? So get into that. And then, of course, you come back around to, Mars is cold. Well, why is it? But it isn't in a way that is shooting them down. It's in a way that is lifting them up. The more that we can encourage that curiosity, the more that we can honor that they are asking questions and interested in engaging and act as a guide for them, well, the more that they can learn, and well, also the more that we can learn too, right? Okay, so thank you so much, everybody. I invite you to try some of this out with your own students, with the learners that you'll be engaging with in the future. And thank you so much.
Hello, my name is Paul, and I am part of the Incredible Education Department at the Clark Planetarium in Salt Lake City, Utah, USA. Prior to that, I recently retired from teaching kindergarten through 12th grade students, with most of that experience with 6th through 8th grade middle school students. I also mentored teacher candidates from several universities in California and Utah since 1986. From 1978 to 1982, I was a Disney Imagineer at Wed Disney in the engineering department. I want to thank you for the opportunity and honor in sharing a lesson that has proved to be of great value to us here at Clark and to the students that we presented it to. Today, I'd like to introduce that lesson that we created to present to pre-K and second grade students on the NOAA Science on a Sphere and how it can be adopted and adapted to be presented in the classroom. As you can see, the SOS Science on a Sphere is a 6-foot diameter screen in the shape of a sphere. That, with computer programs and 4 projectors, we can produce a dramatic visual. Ours is accompanied by 4 65-inch flat screens above it to use to provide details and accentuate what is projected on the sphere. You are looking at an example of our lesson, Sun, Earth, Moon. We recommend it for 2nd through 5th grade students. Many lower grade teachers would choose this lesson because it was the closest to their needs for their students in lieu of not having one for their grade level. For this reason, we chose to create a program that would satisfy the curriculum needs and to engage the younger kids specifically. Younger kids yearn to be read to share a book. We took this concept and turned the SOS into a giant picture book. We wrote a story that covered the core curriculum for that age group and added graphics that would appeal to them. In addition, tactiles were added to make the kids part of the lesson. I will cover them in a moment. But first, let's take a look at student attendance and the lessons that they attended. Specifically, if we are looking strictly at the numbers, the graph shows the success of offering an age-appropriate lesson. Please look at the second bar from the left of the 2023 graph. It represents the lesson Sun, Earth, Moon, or SEM. It includes approximately 3,000 students in the K through 2nd grade out of almost 8,000 students that viewed that lesson during the 2023-2024 school year. If you look at the program in 2024, we have added Sun, Earth, Sky. In 2024, 4,000 students viewed Sun, Earth, Sky, more than the previous year that viewed Sun, Earth, Moon. Still, the number grew for 3rd through 5th grade if you look at Sun, Earth, Moon right next to it. More importantly, received praise from both teachers and the kids from the new program. To continue, let's take a look at some of the slides from the Sun, Earth, Sky program. For these next few examples, you'll be able to see what is on the sphere, the flat screen, and the story itself for that page. Right now, you are looking at what the kids would see on the screen alone. Here, you see that we have a nice cheery sun face on an image of the sun. This is on the sphere. On the screen above it, we have this image of the sun plus the word sun, and below it is where the closed captions will come with the script. Below is the script, and we chose not to have the script on the screen page because we use a closed caption system that shows the words as we read it to it across the screen in this area. It also includes a language translator, so if needed, we can use it in different languages to help those classes that have second language students. This is a space on the slide also, though, that if you'd like, you could put the script right here so that kids can read it along with you. The questions are key. If you look next, we have engagement questions. Who likes the sun? Why? What do you like to do when the sun is shining? What is the weather like outside? Hands fly up to answer those questions. More fly up to ask more questions, and we are inspiring inquiry. At this point of of the program, you're probably wondering, what if we do not have an SOS system? Well, in the classroom, this all can be done on a smartboard, flat screen, or projection system, which allows you to have your own personal picture book fill for a big group. You create the slide presentation, and then in place of the sphere, you use 3D tactiles and visuals that I will cover next. Here we go. So above, you can see a picture of the Earth. But at this point, if we were using the sun would be up here, and we would be using this Earth, a pea-sized ball would be the size of the Earth in comparison to a sun here. But if you do not have that, we're able to depict the sun using a smaller 3D version of it. And if you look real close below, you can see the BB that we found that would represent the Earth in size. So to depict size, if the sun is the size of the model, the small ball bearing in front model represents the Earth. We were able to find these items by first finding a model, sun, and then doing the proportional math, finding an object the size of the Earth, which is the BB. I have also used butcher paper to make a 6-foot diameter sun to hang and use a pea-sized ball that the kids can hold to compare. Moving over to the next picture, this goes along with our slide. The sun helps move the water. So if the sun heats up the water, it will create a mist, and we can spray the mist out of the spray bottle, and the fan could be used as the wind moving the clouds along. Another good experiment that you could use is cloud in a bottle. You can look that exactly up on the internet and find the experiment, and the kids love watching that. Also, we have this 2-chambered aquarium that we put hot water as red in one side and cold water in the other, and you can see the steam coming up from the heated water. The next slide is the Earth. And again, here is the Earth that we have on the sphere. And here's the slide above and the area that you could put the graphics, or that we use the closed captions. I will read this to you. Hello, I am the Earth. I am where you live. I am where many, many, many other things live. Some engagement questions can include, can you name some things that live around us here in Utah? What are some of your favorites? What about trees and plants? Do you think they're alive too? What do plants and animals need to live? Here is a animated graphic that we use to show the water cycle. The sun helps move the water. And as you can see, it shows the heating process and the evaporated water rising, coagulating on dust and bacteria and creating clouds and getting so heavy that it rains and snows. And the water comes back to the Earth to recycle and circulate. We also want to cover the seasons for this grade level. And here we have what is on the sphere, and inside the picture on pips, we show different weather and different seasons. And then on the slide above on the screen, we show the 4 seasons, and we can question the kids which season is which. Some of the script is, what does the sky look and feel like outside now? And you can talk about the season that you're experiencing with the kids at that moment. I'll give you a moment to take a look at these questions and script. This is one of the final slides, and we call it Thank You, Sun, Earth, and Sky. To conclude this part of the story, we say goodbye to the sun, the earth, and the sky. Before we say so long, let's say thank you to the sun. I am the sun. I make light. I make things warm. I help things grow. I am the sky. I am the air. I hold the clouds. I help move water. I am the earth. I have water. I grow life. Remember to have fun learning and exploring. Now we say so long. And the final slide, we said, before we go, here I am again. I am your sun. I warm up your days and light up your sky. Did you know that I have other friends orbiting me? This last slide is an introduction to the sun and its friends, the planets, opening up more wonder to what is out there. Perhaps this is more of a reading lesson than science, but please remember, by fostering reading skills and by encouraging conversations, making predictions and questions while reading, you help kids understand. Sharing books opens up new worlds, especially with space content. It encourages children to dream big and think creatively. Again, creativity is intelligence having fun. With basic reading skills such as encouraging conversations, making predictions, and asking questions, along with a little fun, you help kids understand. Sharing books opens new worlds, especially with digital content about space. It helps children dream big and think creatively. At the bottom of this slide, if you have any questions or would like to discuss anything with us, there is the email that you can get a hold of us with. And again, thank you so much.